All right, so as I said, this is our last section in this unit of the course. It's on graphing linear inequalities. Okay, so we'll be drawing in some lines. Okay, so we'll take a look at slope. Okay, we've done that before. Y-intercept. Okay, so that should be review. And then we'll talk about how we shade in. Okay, so basically, what is a linear inequality? You guys have already seen stuff that looks very similar. Okay? This is a linear equation. Okay, so you just have to watch this. An equation has what kind of sign in it? What do we call that? Equals. Okay? If you take and replace the equal sign with one of these four symbols, now you've changed it into an inequality. Okay? So x minus 3y, and just pick any one out. Pick less than. Okay? This is a linear inequality. Okay? Okay, any questions on that? Okay, so the next thing is, what is a solution to this? Okay, so for example, if let's say I had an equation like this. What's the solution to that equation? Huh? X equals 1. Okay, x equals 1 is the solution. It's the thing that you can plug in, and it makes it true. In this case, 1 plus 3 gives me 4. Okay, let me show you with an inequality. Okay, with a linear inequality, you don't just plug in something for x, but you plug in something for x, and you plug in something for y. Does anyone remember what we call that? When you have something for x and something for y, and you have the parentheses with a comma between them? It's a coordinate. Okay, so what makes this true is a coordinate. Let me show you one that would make this true. Which one is x here? 2. Which one is y? 3. Okay, watch what happens if you plug 2 in for x and 3 in for y. What's 2 times 2? 4. Plug y in, change it to 3. What's 4 plus 3? 7. Is 7 greater than 5? Yeah, this is one answer. Is it the only answer? No. You can pick any number for x, any number for y, as long as when you fill them in, it comes out bigger than 5. Okay, here's something that's not a solution. 0, 1. Okay, that one wouldn't work. If you plug in 2 times 0, you get 0. 0 plus 1 is how much?
1.
1. Is 1 bigger than 5?
No.
No. Okay, so that's a point that doesn't work. Okay? So we're going to try to find all the points that do work, and we can't write them all, because there's infinitely many. There's millions of points that work. So what we do is we draw a picture. Okay? Just like when you guys did a number line and you shade, it's the same idea. We're going to draw something and shade in. Right? So any question on that? The solution to this kind of problem is any coordinate such that when you plug it in, it makes it true. Just like this example right here. That's a solution to that inequality. All right. All right, so this will be the last part, and then your notes are going to start. Okay. What I want you to just look at this part, just start reading where it says the boundary line. Okay. There's a line that you have to draw. Everything on one side of that line is going to be the answer. Everything on the other side of that line isn't going to be. Okay. It's going to look kind of like that. Okay. So I'm going to show you how you draw this boundary line, and then either everything above that line is the answer, or everything below that line is the answer. It's only one of two options, and it's very easy to figure out which one it is. Okay? So this area that we end up shading in, does anyone remember the name of this whole thing, this grid? What's this grid called? Matt? It's a coordinate plane. Well, if you draw a line in it, and you only shade on one side, if you only shade half of the plane, that's the name of that shape in yellow. That's called a half plane. You're drawing a line, and you're shading half of it. And then the other half, we don't shade. So any question on what that word means, half plane? Just you draw a line, and you shade on one side of it. That's half of the plane. This is what all your answers are going to look like. Something like that today. All right, so now let's get into your notes. So step one, okay, you got to draw this boundary line. Okay, got to draw this boundary line. How do you do it? Just like we've always graphed a line. Okay? You've got to get it in y equals mx plus b form. Okay, just to kind of remember that, what's the m?
Slope.
That's your slope. What's the b? Yep. Y-intercept. Okay, so the only difference is it's not going to be y equals mx plus b. That equal sign is going to change to one of those four symbols. Less than, greater than, okay? It's going to be one of those four symbols. But the whole goal, you got to get y by itself on one side, just like we've always done. There's no tricks, nothing different. Okay, one thing you might have to do. If x is on the same side as y, that's no good. You got to get x on the other side. Okay, and to do that, we use the opposite operation. Okay, let me show you an example where you'd have to do that. Okay, where x would be on the same side as y. Let's go like this. Okay, are x and y on the same side here? Yeah. So this step says move x if it is on the same side as y. How do you do it? Use the opposite operation. Yeah, you'd minus x. Minus x. So now you have y is less than. And who can tell me how I should write it on this side? You want to get it so it looks like that. So what has to come first? Yeah? Okay, and what kind of x is it? Positive or negative? It's a negative x. What else do we have? What kind of 4? Positive or negative? Positive. This is how you do that step right there, if you had to. Okay, just move x to the other side. Sometimes there might be a number attached to y. Okay, a number right next to the y. If you've got a number attached to y, you're going to divide each side by that number. Okay, that's not anything new. That's something you guys have been doing to get y by itself since November. We're just putting the steps up there again, so if you don't remember how to do them, you can see them again. Question on that stuff? Okay, so I'll show you an example where you'd have to do that. Okay, let's look at this one. 2y is less than 4x plus 8. Is y by itself here? What do you think? How about Sam? No? We've got a number attached to y. How do you get rid of that number that's attached? Yeah. What do you divide by? 2. And where do you do it?
On both sides.
Both sides. So there, where else?
Like on what number?
Yeah, where should I do it? You guys okay? All right, so we divide by 2 here, and Matt, where else? Okay, guys, focus back up here. You do it on everything. Okay, so if you've got a number attached to y, you got to divide by that number everywhere. Okay? And then you can simplify whatever you can. 4 divided by 2, divide by 2. Okay? That's how you do Step 2. Okay, you just have to divide everything by 2. Any question on how to do that? It seemed pretty straightforward. It's not bad. Okay, so now the slope. Remember, if you have the number with x, if both the top and the bottom are negative, remember that cancels out. And you get positive. So if the number next to x has a negative in the top and the bottom, kind of like this. Let's say that was the number next to x, -3 over -2. Remember to cancel those negatives out. Okay, and the last thing with your slope is you always reduce it if you can. So if you had a slope that was, I don't know, 10 divided by 5. 10 in the top, 5 in the bottom. What could you reduce 10 divided by 5?
Half.
Yeah, it reduces, well, no, not a half. That'd be 5 over 10.
2 over 1.
You're 2 over 1, good. Okay, so if you've got 10 divided by 5, you make it 2. Okay, so that's step 1. Okay, that's step 1. Get everything, so y is by itself. Any other questions on step 1? Okay, step 2. Now once you get y by itself, now you have to draw it. Okay, what do I mean by now you have to draw it? You've got to draw this line. Okay, now we got to figure out how to draw it. What are the 2 letters that affect how your line is going to look? No, not the x and the y. The
M and B.
The m and the b. What is the m affect? That's your slope, and the b? But William, what's the b?
Y-intercept.
That's your y-intercept. Okay, so remember, when you want to graph your y-intercept, you just start at that number on the y-axis, and you put a dot right there. Okay, so let's say you had something like this. If I wanted to graph that line, okay, we got to draw that line in first. I'm going to put a dot 3 units up on the y-axis, just like this. Okay, that's my first step. Okay, once I look at the y-intercept, what's the other number I got to look at? The m, which is slope. Anybody remember what slope is? Sometimes we use 2 words, they both begin with R. Rise over run. Good. Okay, so once you put a dot on your y-intercept, then you use your slope to graph another point. Okay? Rise over run. In this case, I just have a 2. There's no fraction there. There's nothing in the bottom. But there's a number you could put there to make that a fraction. Anybody remember how you could make 2 into a fraction? Yeah, you just put it over 1. Just put it right over 1. So now, Mr. Roy wrote out, how do you know which way to go? From this point, you've got 4 choices. You could go up, you could go down, you could go left, or you could go right. Well, you look at your rise. If your rise is positive, you're going to go up. If your rise is negative, we go down. Then we look at the run. If the run is positive, we're going to go to the right. How many do you go to the right? Well, just look at the number. Depends what the number is. If the run is negative, you're going to go left. Okay, so what would I do on this one? I got my y-intercept. It's at 3. Now, which way would I go from this point? Would I go up or down from this point? What do you think? Look at my rise. Okay, Tyler, what's my rise in that problem? 2. Positive or negative? Positive. So which way do we go? Up. We're going to go up because the rise is positive. Up 2. 1, 2. Now look at the run. Hey, Isaiah, what's the run here?
1.
1. Good. Positive or negative?
Positive.
Positive. And if the run is positive, which way do we go?
Oh, wait, no. To the right.
To the right. If the run is positive, we're going to go to the right. Okay? Run, positive, right. Any question on that? So up 2. How many do we go to the right, though? 1. Up 2. Right 1. Okay? And then you draw your line through those dots. Okay? That would give you your line. Right? So you graph your y-intercept, then use your slope to get one other point. Okay, now the last part. What kind of line do you draw? Okay, it's four different cases. Now you can either shade above or below the line. Just like we had in that example I showed you back here. The two choices are either to shade above or below. Where do you think you'd shade for less than? I think less than. Does that sound like it would be up above? Or would less than be below? It would be below. Okay, it would be below. And we have two choices of lines. Just like when you draw your circle, you got a closed circle and an open circle. We kind of have the same thing with a line. We either draw in a solid line, or what other line do you think you could draw? Besides solid.
Dotted.
Yeah, like a dotted line. If your inequality is a less than, think less. Less is below. Okay, below, and it's dotted. What about less than or equal? Do you think you're going to shade above or below?
Below.
Yeah, you're still going to shade below. Less than is below. But what kind of line do you think you'd have instead of dotted? Yeah, it would just be solid. All right, now when you think greater than, where would you shade for greater than? Yeah, greater. Greater is up above. Okay. Anybody have a guess though? What kind of line? Solid or dotted?
Dotted.
Yeah, it's dotted. Okay. Anytime you don't have the little line under it, it's always dotted. Okay, and then the last one, greater than or equal to?
Above.
Yep, you're still shading above, except now you got the little line under it that tells you got to make it solid. Okay. And that's it. Those are the only 4 cases. Okay, I think on your paper it does say special cases. There's only 2. We'll talk about the special cases after. Those are easier. These are harder. So if you understand this, special cases are easy. Okay, any questions before we look at an example?
There's a second part.
Second part?
Yeah, we're doing special cases.
Yep, we're going to do the special cases a little bit. Okay, now we're just going to jump to these examples. What's nice is these examples, once you know how to do it, they take like 30 seconds. They're really, really fast. Okay, so everybody have the sheet? Did I pass out the second one? You got that one? Okay. Before I even draw anything, am I shading above or below? What do you think? Below. I've got a less than, and I'm going to shade below. Oh, for the boundary line, is it going to be a dotted or a solid? Dotted, yeah, good. So that's already 2/3 of the problem you've got to know, and we haven't even started. So we're already almost done. Okay, now we got to draw this. Which number do you look at first, the 1/2 or the 3? You look at the 3. Where does the 3 tell you to go?
Positive.
Yep, up 3. If it was negative, you'd go down. Right? Now we looked at the 3. What's the next number we look at? The 1/2. In 1/2, what's the rise? That's the rise. What's the 2 called? That's the run. Is the rise positive or negative? Positive. So if your rise is positive, which way do you go? You go up. So we're going to go up 1. And my run is 2, and it's positive. So which way is positive run? To the right. Up 1 on the rise. Go 2 to the right on the run. And now draw a line right through those points. But what kind of line is it again? Dotted. Okay, and now last step. Let's do it like this. Okay, we got to decide, do we shade above or below?
Below.
Yeah, how do you know it's below?
Less than.
Yeah, anytime you see less than, shade below. Okay, so shade, what I would do to shade it in, all you got to just draw like that. Okay, if you want to shade it nicer, you can, but you don't need to.
There you go.
That's it, that's the whole problem, you're done.
Wow.
You shade below because it's a less than. Okay?
Why are you shading the first place?
Because every single place that I've shaded, somebody pick a coordinate somewhere in the area that I shaded. Any coordinate you want. -3, 2. No, that's not in the area I shaded. Look. So that, nope, that's not in the area I shaded.
-5, 2.
Yeah, so I heard somebody say 2 comma what?
It's a -5, 2.
2. So let's pick 2 comma, give me a number.
-5.
-5, sure. Go all the way down to -5. Go -4, I heard that, that's fine. Any point in this area, if you plug it in, it will work. Okay, let's try it. Okay, this is the only one I'm going to try this for, because I just want to, somebody asked me, why do you shade? Let's plug in. What's the 2? Is that X or Y? That's X. What's the -4? Y. Fill it in. -4 is less than. What's X again? 2 plus 3. Now you could have picked any point you wanted. Any point that was in this shaded area. We just picked one to try it. What's half of 2? 1. What's 1 plus 3? 4. Is -4 less than +4? Is that true? Yeah. So does that answer the question why we shade? We're just marking everywhere that there's an answer. Okay? Any point in this area is a solution to that problem. What happens if you pick a point you think up here? No. What does no mean? It's greater than. Yeah, it would be greater than. So would it work? No, it wouldn't work. All the solutions to this problem are below the line. Okay, because we had less than. Remember, less than, below. Greater than, which way is greater than? Above. That's all you gotta remember. Less than below, greater than above. Those are the only two cases. We're okay with that one? Okay, let's try this one. Who can tell me my first step? Go up one and do what? Oh, yeah, line, yeah, let's put the line under it, good idea. Okay, so we go up one, and what do I do when I go up one? Make a little circle, yep. Okay, so now you looked at the one. What's the next number you gotta look at? -2, uh-oh, wait a minute, it's not a fraction. Sure, -2, what did you say, Tyler? Put it over 1. Who can tell me, what's my rise in that fraction? -2. What's the 1?
The run.
That's the run. Okay, look at your rise. Is it positive or negative? Negative. What does negative rise mean? Down. Down how many? Down 2. What about the run? Positive. Which way is that? Right how many? Good. Now what are we going to do with the 2 dots?
Solid line.
Make a line? Why is it solid? Good.
This is a line underneath the,
Exactly. And you got that little line under it. That extra line right there means you got to draw that line in. You got to make the whole line. Okay? So make your line. Now our 2 choices, we shade above or below. Yeah, Isaiah? A ruler? You know what? Just use the edge of your ID. That'll work. Just use the edge of your ID.
That's the best idea.
Okay? So now, where do I shade? Above or below? Laura? What, below you said? Okay, why'd you say above? Let's go back and check. Okay, when I see above, I'm looking for that symbol or that symbol. Is that the symbol I have here? Yeah, below. Okay. Everyone see why we're shading below? Just shade below. So if I picked any point where that's shaded in and plugged it into the problem, would it work? Yes. What if I picked a point up here where it's not shaded? Would it work? Okay. I don't think some people understand what the shading is. Who can tell me, what does the shading mean? What does it represent? Yeah. Yeah, it's the answer. It's all the points that are answers to this problem. So if you said, well, what's an answer to this problem? I'd say pick any point you want in the shaded area. If you wanted something that wasn't an answer, pick something that's not in the shaded area. Okay, so everyone see what Dominic just said? Okay, the shaded part, that's the answers. How many answers are there? How many points are in the shaded part? Yeah, a lot. Infinitely many. Any point forever below that line.
Yeah, it's like when we do with the ands and the ors, right? Or even when we were doing this basic inequalities, right? We did like x is less than 2, right? And we shaded everything in. Those were all the answers, right? We had something that like kind of looked like this. And we had like x is 2, right? Then we put a open dot at 2, and then we drew a line that way, right? That's how we graphed our inequalities. We're doing the same thing here because x could be an answer. X, any one of these numbers could be the answer for x. Just like any one of these coordinates could be an answer for x or y. That's why we're shading that area. That's where all your answers show up. Just like when we do ands and ors and all that stuff. Those are all your answers.
And like Mr. Roy just said, anything. Any coordinate you want in that shaded area, those are all answers. All of them.
Why they?
Oh, it was an arrow. Why was it an arrow? Oh, because I had the arrow. Yeah. Okay, now the two special cases. Let's take a look at those. Okay, notice what we got here. Y by itself, then a number. Y is by itself, then a number. Look at the one we had before. It had an X and a Y. It's like we lost a letter. Okay, we just have one letter. Okay, well, when you just have one letter, that's a special case. Okay, if you just have a Y, that's a horizontal line. Okay, Y, inequality, then a number, that's a horizontal line. Horizontal, left to right. Now, if we talk about shading with that, horizontal. If you've got a horizontal line, would everyone understand what would be above and what would be below? Like if I drew a horizontal line, can you visualize what's above that line and what's below that line? Yeah, that's easy. Above, up here. Below, down there. So we pretty much use the same rules. Less than or equal, shade below. Greater than or equal, shade above. But look at vertical. Okay? This is a different case. When you get X by itself, okay? X, symbol, and then a number. There's no Y, just X. Would it make sense to say above and below on a vertical line? Would you understand where above is and below is there? Does that make sense? Justin, what do you think? And if I pick a vertical line and I said, tell me which side is above. It's kind of weird, isn't it? Okay, so for a vertical line, we can't really say above and below. But what we can say is left or right of it. So you either end up shading on the left side or the right side. And you can either remember it the way we've written here, or just look at the original problem. The symbol tells you which way to shade. So look at this one. X is less than or equal to -5. Which way is the less than pointing? Which way is that less than pointing? To the left. Okay. So in this problem, if you did it out, you would shade to the left. How about this? X is greater than 2. Which way is the greater than pointing? Marcus?
This way.
Which way? To the
right.
To the right. So if you did this problem, you would shade where it's telling you, where it's pointing. You would shade to the right. Okay? So even though there's special cases, they're actually easier. You don't have to draw your slope. You don't have to do an intercept. You're just drawing a horizontal line, add a number, or a vertical line, add a number. That's it. Okay?
Guys, that first special case, right, the Y is greater than 3, right? Where are you gonna graph? Like on what axis? X or Y? Matt, what do you think? What axis are we gonna, that Y, right? Our point, right, our little point that we have to graph, where are we gonna put it? For the first special case? Not the whole line, all right? So we got, here's our number, all right? Ben, which one's the y-axis? Up and down, right? Good. And there's our x, right? So Mr. Hager's gonna put it on there, right? So we get the x and y on here, right? So if I got this, right, I'm going to talk about it in a second, I just want to show you. Matt, if I got this, where would I start, where would I put my point? Where? On the y-axis, where? 3, right? Positive 3, so am I going up or am I going down? Up. 3, right? So like one, so it kind of be right here, right? What Mr. Hager means by horizontal is we want to go this way. All right, KJ, for this one, say if I had like x less than or equal to -5, what would I do? X-axis, okay. Then, huh? -5, so am I going left or am I going right? Left, right? Negative's left, so I'm gonna go like over 5, right? So kind of like in this region, and like Mr. Hager just put there, he'll do this one because we got the line underneath. What kind of a line am I gonna draw? What kind of a boundary? Solid, right? Good.
Did everybody see why I changed it to dotted? You want to see that?
I want KJ to get mad at me. All right, so that's just how those work, guys. Always, when you get something like that, like the special case, X or Y alone, I always think of it as draw my line opposite the axis, right? It's a Y, it's a Y, it's a Y, so draw my line opposite the Y-axis. It's an X, draw my line opposite the X-axis. That's how I remember it. And this the point you have to graph it right on that axis. If it's a Y, graph it on the Y-axis. If it's an X, graph it on the X-axis. That's all right?
All right. So what's the first thing I should do? I'll pick up my pencil. That's the first thing I should do. What's the second thing I should do? Shelby? Go to +2. Which way? What? So what kind of line is this? This is going to be.
Oh, never mind. You're going on the Y.
Yes. Go on the Y-axis. Up how many? 2. Now what? Yep. Filled in line, solid line, horizontal. Good. Okay, last thing I have to do is decide, am I shading everything above that or below that? Who can tell me if it's above or below? Got that? Above? What tells you it's above?
What's the hint that tells you that you're shaped above that?
Yeah, the gradient. Good.
Think of it, right? Y is greater than or equal to 2. All the numbers that are greater than 2 are going to be in that part of the graph.
Everyone see that? What Mr. Roy just said? You're just basically picking all the Y values above 2. Everything above 2. Doesn't matter what X is. We don't care about X. We just want to pick Y values bigger than 2. Any question on that one? Okay. All right. How about this one? X is less than 3. Everybody tell me what I'm going to do first. Marcus?
You're going to put 3 on the x-axis.
Yep, 3 on the X. Which way is 3?
To the right.
To the right? Okay. Now what?
The line's going to be going up and down.
Yep, up and down. What kind of line?
It's going to be a dotted line.
It's going to be a dotted line. Perfect.
Marcus, you know what I like? You looked at your reference, you looked at your notes. That's
Yeah.
okay. It's, all these things are dotted, shaded, above, below. It's hard to remember. That's why Mr. Hager and I put the notes on 2 separate pieces of paper, so you didn't have to keep flipping back and forth to see what it was. That's why it's on 2 separate pieces of paper.
Okay, now the last thing is to figure out what side to shade on, but use that inequality as a hint. Yep. To the left. It's pointing left, shade left. Okay. Any question on that one? So it's everything to the left. Okay, so we got 2 more and then we're done. Okay, 1 more I think is on your sheet. The next one, I'm just going to have you watch me do on the board. Okay? Does everybody have this one on their sheet? Is that one there?
Yeah.
Okay. On your sheet, is the line under it? No. All right. So you know what? Let's do it without the line. What's different here? This one's a little different.
I'm not sure.
2x minus y.
2x minus y is less than 3. What do I got to do first? I got to get y by itself. Good. Anybody tell me what's my first step? Subtract what? Careful, there's something with the 2. The x. Subtract 2x. Subtract 2x. Okay, and I get negative y. Now, what should I write on this right-hand side? Remember the order we talked about we wanted in? Mx plus b, good. So that,
Your negative 2x
yep,
plus 3.
plus, perfect, that's exactly it. Good.
Remember, guys, some people, I don't know if we talked about this when we did graphing. Some people might have to do it like this, where you circle your negative 2x and bring it over there. All right, some people forget. Because again, you're right, Tyler, you were right, minus 2x, but look it. What's this have to be able to combine it? No, what would it have to have with it to be able to combine those two things? X. What would this have to be able to combine it with that? This has to be negative 2, right? That's what, it's almost like you're writing out the fact that you can't combine like terms. Like you're writing it out like, I can't combine like terms, so I just have to write it out. When I write it out, I gotta make sure that my x comes first. That's the order it has to be in. Okay?
All right, now, do we have y by itself? No, we're close. What's still stuck to the y that we want to get rid of?
The negative, so
That-
you divide by negative 1.
Right, divide by negative 1. So I was just going to ask, if you weren't sure, put in a negative 1, then you can see the number that's there. Does everybody see that? That's perfect. Okay. So divide everything by negative
We
1.
get to the end, right? And like we said this before, we did regular slope intercept. We're not just dividing by negative 1 just for the fun of it, because we're really good at it, because we have to get y by itself. That's the reason why we're doing it.
Flip your
It's not just for
sign
fun. Well, maybe Chelsea's doing it.
Exactly. Why am I going to flip my sign?
and divide it by
By negative.
Right. A lot of people miss that. They forget that rule. They're like, oh, we're doing y equals mx plus b. They forget to flip. That rule still applies.
That's why we picked this example.
Now, look at this situation. What did we say about that situation right there? Yep.
If you divide by negative, it's going to be positive.
Negative divided by negative
You can't touch
is a
that.
positive. Good. How about this situation? Positive 3 divided by negative 1. What's that? Negative what?
Negative 3 over 1.
Negative. Yeah, you can write negative 3 over 1 or just 3 divided by negative 1, just negative 3. Now if we got y by itself.
Yeah.
Good. Okay, who can tell me my first step to graph that?
Sam Mans, what do you think? What would Mr. Hager do first to graph that?
Go down.
Good job, Sam.
And what do I do right there? Put a dot. Okay, now we looked at the negative 3. Now we got to look at the number next to x. What's that number again? That's the slope. Okay. What's the number in the top? That's a 2?
Rise.
Rise.
That's the rise.
Up 2.
Okay, when the rise is positive, up 2.
Over 1.
Which way's over?
Right.
Right 1. Okay, now I got my dots. Now what?
Right.
You're going to have a
Dotted line.
dotted line.
Yeah, why is it dotted?
Because there's no line underneath the y is greater than.
Yep.
And you have to shade it and below.
Now we got to decide where to shade.
Below.
What kind of symbol is this?
Greater than.
Greater than. So like if you think greater, greater is what?
Above.
Above. Greater
Oh, yeah.
is above. Shade everything above. Okay, it would keep being shaded. I just didn't want to write over all our work. Okay, any question on that? Okay, now the last one, then we're done. We're going to switch it up. I'm going to give you the picture. Okay, there's your boundary line. There's your picture. I want to know, what would the inequality be? What do you think I should figure out first?
Where your points are.
It's overrun.
Or
Yeah, I should figure out my slope. That's good. What else do I need to figure out?
Your main point. Is that your B.
your x-axis.
So I like slope, we want to get slope, but I want something else. I haven't heard anyone say it.
Even before that, right?
Starting point.
Good, right? But even before that, to write, for Mr. Hager to write that inequality, what's it gonna start with?
Find your dots.
What's it gonna start with? What letter? Y. Put the Y first, right? Because you know for sure that doesn't involve any math at all. You know because of the formula, it's gonna have Y first.
Now, we got to get our symbol, but we'll get the symbol last, okay? Let's, how do I get slope? What is that? And look at, they gave me 2 points right here, so how do I figure out the rise and the run?
Find your y.
What do I do?
Find your y.
No, I want to get my slope. I want my slope between those 2 points. Yeah, just count. 1, 2, 3, 4. What is that?
4/4.
Well, the 4 is my,
Top number or bottom number, guys?
Both.
Rise, right?
rise. Now we're going to go which way? 1, 2, 3, 4. Where's that number go?
Underneath.
What is this? What did we just find? This is the slope. Okay. What letter always goes next to slope? X. Okay. We'll reduce that in a minute. Now I got to have something else on the end here. Well, yeah, my B.
What's the B stand for? Ben, what's the B stand for? Not Ben, Mom. It stands for what? In the slope intercept form. What's B stand for? What's y-intercept mean, Ben? Anybody help Ben? What's y-intercept mean, Shelby? It's where you start, right? But how do you know where it is? Intercept. What does intercept mean? You're crossing something. What are we crossing? The y-axis, right? The y-intercept is where your line crosses the y-axis. All right? So in this case, if we look at it, what point does the line, the red line Mr. Hager has up there, where does it cross the y-axis?
On 4.
Good. And it's positive 4, right? So I'm going up 4.
Now, just a coincidence here that we had 4/4 and the y-intercept was 4. Just the way it happened.
Would it be negative
No,
though?
because it's up 4. 1, 2,
Yeah,
3.
but then from your starting point, you go down 4/4.
So the y-intercept is on the y-axis. What number is that? If this is my origin, this is up 4 from the origin. Down 4 would be down here.
I think,
No,
Yeah, but
what
if you
you
start
mean
at the
is
Y and go
that
left.
I know
you
what you're
went
saying.
up 4 and over 4.
You always start from the origin.
No, from your
Yeah.
4, you
from
go
your
down
origin,
4
Mr.
over 4.
Hager, Kayla's saying you're going down. So
So it's
for your
negative
slope.
4/4.
Okay, you know what? Pretend when you're finding that point, pretend nothing else exists. Just look at that point right there. Just count from the origin how many up.
But I think what Kayla's saying, Mr. Hager, is for the slope, to get to that next point on the x-axis, you're going down. You're going from your y-intercept 4, you're going down. Because if you rise first, so you go down. Down and over, right?
Well, I would look at it as I'm going up and over. Up and
Oh,
over.
Wait, why would you?
okay.
Up
If you
and
go
over.
down and over, then that's going to lead you to the right.
Yeah.
You go
So
over
I see what you're
again.
saying.
since we're going up and over for each
Down
point.
and over?
Because what Mr. Hager's saying, watch what happens, guys. If I go up 4, right, like the slope is telling me, 1, 2, 3, 4, then I go over 4, 1, 2, 3, 4. I'm gonna land right on the line. And then, like we said before, if we do the opposite, we'll get the same thing. If we go down 4, left 4, 1, 2, 3, 4, left 4, 1, 2, 3, 4, we'll get the
That's what
same
I
thing.
meant.
I know what you're saying. I know what you're saying, Kayla.
So it's like you can go up the stairs or down the stairs. It's the same thing. Yeah. See what I mean? Okay. Now we got to decide on the symbol. What kind of symbol do we need? Look at where we shaded.
Above.
We shaded above. What are your 2 choices when you shade above for symbols?
Greater than.
Greater than?
Or
What?
greater than equal to.
Or it could be greater than or
But
equal.
it's greater than equal to.
How do you know it's greater than or
It's a
equal?
solid line.
Right, solid line. So above, solid line. Okay, last step. What's 4 divided by 4? Let's reduce
One.
that.
One,
1. So do we need to put the 1 in front of the x?
no.
No. So there's the inequality that I drew right there. Y is greater than or equal to x plus 4. Okay? Any question on that one? So that's a little different. They give you the answer and then you're coming up with the inequality. All right. So, Mr. Ray, we have a few problems they're going to work on in class now.
This is what I want you to do.